with you. I've even shared some of my older recordings from the same course. So in case you need in case you need that for reviewing your course. Okay. So let me start today's lecture, which is about hierarchical clustering. Okay. So this is basically the last kind of clustering that we will be talking about. Uh, can you see? Let me just give me a second. Let me go out and come back. Okay, so what we will be doing is hierarchical clustering, and this is the last type of clustering we'll be doing. After that, the topic within clustering is not about a new technique, but rather, how we are going to deal with different kinds of data other than numeric data. Okay, we will start here, hierarchical clustering. And what we will do is we will first talk about some of the basics of our hierarchical clustering. There's something called dendrogram. Let me try to use my pen here. So we need to first learn something called dendrogram, which is like used as a basis to perform hierarchical clustering. And then we will then learn about something called agglomerative. And there's one more kind of a clustering that is used to perform this so-called hierarchical clustering. Okay. And there is an issue when it comes to distances, which is different as in k-means or k-medoids. So we'll learn about something called intercluster distances. So there is a difference between, how you measure distances when it comes to hierarchical clustering. And so we'll inshallah talk about that as well. Okay. So let us start. Let us first start by describing what a dendrogram is and where dendrogram is used. So we'll describe some of its uses. And then we'll learn how hierarchical clustering is done and some of the associated topics. So in between, if you have a question, you can use your chat box or you can use your mic as you feel comfortable. Okay, so first of all, let's start with something called a dendrogram. Dendrogram looks like, the tree structure that you're looking at on the screen. So this is a dendrogram that you're looking at, or this is another dendrogram that you're looking at. Okay, uh, and this dendrogram is actually used to show uh, grouping of data in a tree-like form. So when you see uh, two branches very close to each other, it means that they are more similar. When this is like far from each other, this is like they are quite different. So anything close will have not only be together, but also, as I will talk about that, this height of height of a branch is also important in this consideration, meaning that a smaller height will represent more closeness versus taller height will represent not so much closeness. So if I showed you these uh, you know so this is one point, this is another point, so I'm going to call it point one, point two, and I'm going to call it point three, and then I'm going to call it point four. So if you're comparing point one and two versus point three and four, which 2 points seems more closer to you? Is it one and two or is it three and four?
1 and 2,
Yeah, because why one and two? Because
because they are close to each other, and the height is also small.
yeah, that is exactly, you need to understand height also matters. Okay, so a second thing, if you remember from our earlier lecture, hierarchical clustering also does things on incremental basis, meaning that uh, you're saying that these two are close, right? Then when you call them, these two are close, you have just made what you call a cluster. Let's call this C1. Okay. Then this is then you're trying to see similarity between this cluster and this point, and then which makes a new cluster, right? And then so you're comparing clusters of clusters, so it creates like a cluster of cluster, multi-level clustering that we discussed long time ago, when we started talking about the course. So it's not just single level cluster, but it's a multi-level cluster that we are looking at. So one important thing about hierarchical clustering is that unlike in k-mean or k-medoids, you do not have to define k to start off with. You're not doing that. So you do not need to define k. In fact, the algorithm doesn't ask you to define anything. Okay, that's one point, and you'll understand the reason for that as we go along. Okay. Secondly, it does use distance matrix as before, uh, but there is a difference. The distance. What is the difference? I will talk about that distance over next few slides. But to start off with, when you're comparing one point with another point, the distance, the concept of distance is still the same. It could be Euclidean distance, it could be Manhattan distance, but here, because we are not talking about numbers, here we are talking about comparing people. So I'm going to show you another variant of how we calculate distance when you're dealing with qualitative problem. Qualitative meaning that like colors, like shape, the height, and so on. So like comparing people with people. So I'm going to show you how that is done. So again, the dissimilarity between two objects is represented by the height. Again, I told you height is an important consideration. So you can see that these two, these two girls are identified as close. Just by looking at them, you can see that they look more closer, right? They are in terms of height, in terms of age, in terms of their hair color, and many other things. That's why, because they look so close, that this height is small. But you compare these two girls together with another lady here, you can see that this height is tall because there's a difference. But again, you should ask, how we are calculating the distance. We will see, in a minute that, in such situations, how we calculate the distances. But let's first look at, the uses of dendrograms. Dendrograms are used in many places. For example, in website directory, then you can see that dendrograms are there. For example, business and economics is the top level cluster, and then within business and economy you have like B2B, finance, shopping, and jobs. And then within finance you have banks, bond. Within shoppings you have, so this classification and subclassification, where when you're dealing with such problems, you can make use of what you call the dendrograms. Okay, any questions so far? Everybody is okay with that? Can you please drop a word or two in the chat box, please?
Yes, clear until
Okay.
now.
Okay, great. So let us just go forward. Let us look at this numerical example, the clustering example that we are more used to seeing. So if you're doing k-mean clustering over this data, you can perhaps try k equals to 2, right? I told you that there is even a way to uh, uh, determine k, but let's assume that k is 2. So you can see that the k-means will call this one cluster, because we have made it so obvious that you should know the answer automatically. And k-means should call this the second cluster. Everybody agree with that? Everybody is fine with this thing,
Yes.
right? Now, but let me raise one more question. Within the cluster, uh, do you think these 2 points versus this point compared to this thing, what do you see?
For.
Yeah, this point is far, right?
Mm-hmm.
But it is a very, very nice representation of how each point is related within your data set. Okay, so uh, this is basically one of the reasons that some people prefer dendrograms and hierarchical clustering, because it reveals far more information as compared to k-means and k-medoids. Okay, now how do you create this hierarchical clustering? That is the next question. So uh, we can use two different methods. Number one is called agglomerative approach, which is also called bottom-up approach. Okay, agglomerative is also called bottom-up approach. And then we have something called divisive, which is from the word division, right? Divide, you divide, yani taqsim. So, and this
Is it
is
mean the sub of the sub?
no. Yeah, so basically, there are two ways, as I'll show you on the next slide. You can start creating your clusters from these points and then
Mm-hmm.
start merging them together upwards. So you start with individual points, individual point, right? And then you start clustering them like this. This is first cluster, this is second one, then this is like the third one, and so on. But in divisive one, you actually start by calling all of them as a single cluster. So you start at the top. You're starting here at the top. And then
Okay.
then you say, okay, this one looks different. So I'm going to make first division. I'm going to divide them into two. This is one and this is the second one. And then you divide
Okay.
further into, so you rather than you
Ah,
going upward, you keep
you
dividing them.
you mean dividing them from the top many times until the bottom.
Yes, unless you reach the bottom. That's exactly what I'm saying. So this is called divisive. When you're going from up, you keep dividing them. This is called divisive method. But when you're joining points into clusters and you're going up, this is called agglomerative or bottom-up approach. So how do you start agglomerative approach? You start with individual data points as single points, and then you start making clusters at the bottom. Okay, and then you look to merge the nearest one and the next closest cluster and the next closest cluster, and you keep going up. So that's why you call it bottom up. Okay. Divisive, on the other hand, you start with only one very big cluster in which everything, all points are there, and then you successively you divide. The next so I showed you on the previous one. You divide. So and this is why it is also called top down approach. Now, if you look at this example, what do you see in step? And we will look at both. Okay, we'll look at agglomerative approach, and then we will look at the divisive approach as well. Let's start with divisive approach. So, how many points do we have? How many points do
Uh,
you see on the screen?
5.
Five. Can you name them?
A B C D E.
Right. So imagine A and B are the first most closest 2 points between A, B, B, C, C, D, E, compared to everyone. A compared to B, A compared to C, compared to D, compared to E, then B with C, B with D, B with E. So you compare all possible points, okay? So the closest point turns out to be AB. Imagine if that happens. It means what? It means that you will combine an agglomerative approach, you will create a cluster AB, which is formed between AB, A and B, right? So this has become like the first step. The next step is imagine if you find out that the next closest one are D and E, right? So that's why you found D and E. Then, so what is your current level of clusters, okay? So if you look at this, let me change the color. So this is already gone. Why it is gone? Because they are merged into a cluster. We just have to see what is left, okay? Now this is already merged. Between D and E are already merged. So what is left? You have left with
C.
AB, C, and DE, right? So imagine
Why?
C, because AB has already merged, right?
Okay.
That's but AB is the latest one. That's why you're keeping it, right? Because before that you remove anything before you remove, okay?
Okay, we removed A B and then we
Because
removed
why
the
we removed
D
A
E.
and B? Yeah, why we removed A and B? Because we already merged them into,
Okay.
right? Then DE, we merged them into DE, right? But did we merge C yet?
No.
That's why we are keeping it. Okay. Now, next, what you will see is C. C looks closer to AB or C looks closer to D and E. So as it turned out, maybe there was somebody who's doing the distance calculation that C is close to DE, right?
Mm-hmm.
So you merge C,
Okay.
D in together. Now, because C is
Okay.
merged, D is merged, so you remove both of them. Now, what next? What is left?
The CDE.
And
Uh, ABCE. No, just I mean CDE and AB.
yes, that's correct. So next, what you do is you merge the remaining one, and then it becomes you remove this one. So this is like A, B, C, D. This is agglomerative. You're adding them like this based on distances. But you should ask me one question, which I'm not going to answer now, but I'm going to answer after a little bit of a distance, after a little bit of, after like 5, 7 minutes and next couple of slides. How do you know if A is more close to B versus A close to C? What is the method for finding, whether A is close to B or A is close to C? You have done
We
that
use
in k-mean clustering, and you
we
have done
use
that in k-medoids clustering as well. What is the method to check that?
we use absolute or Euclidean method.
Yeah, so you exactly have to do that, right? So whether you are comparing distance between AB and distance between AC, AD, AE, right? Like whether you're using the Euclidean distance or Manhattan distance, right? But let me ask you one more question, and I want others to respond to that as well. And I'll keep an eye on the chat box. When you're trying to compare the distance between C and
Doctor,
AB, yes,
the Manhattan, is it the absolute value?
yeah, it is the absolute one.
Oh, okay.
Okay, so uh, when you're comparing the distance, okay, you used to use, can one of you tell me the formula? Because that then it
Uh,
becomes important. Let's
X minus X1 minus X2
If there are only two features, right? If there are only two features, then you x1 minus x2. Okay,
square
then,
plus
yeah,
Y1 minus Y2
y1 minus
square
y2. Okay,
square.
imagine if there's a third one that you would have done it like z1 minus z2, and then there's another one, you add another one and so on, right? So,
We use the third uh, not the square root. We use the three. There is an option in the calculator. We put three above the line.
yes, yes, yes. So, let me ask you. So, you know that A is x1, y1, right? A is x1, y1, right? B is x2, y2. And you compare, that's fine. Okay, but what about when you compare AB with C? C is x1 comma x2 x3 comma y x3 comma y3. But what about AB? AB is not 1 point. Do you understand my problem here? How do you calculate distance? Because A
Mhm.
within this cluster there are 2 points. So which one of you would you use? Would you use x1 x2 or x1 y1 or x2 y2? Which one would you use? You understand the problem. So this is where hierarchical clustering is slightly different when you're comparing a cluster with a point or even cluster with a cluster. How do you find distance between one cluster that has point AB, and how do you find the distance between a cluster that has 3 points C, D, and E? So we are going to talk about how we are going to measure distances in such situations, which involves distance between a cluster and a point or a cluster with another cluster. Okay, we're going to look at that, but for now, you understand that there is somehow we are measuring, the distances. Okay, so I'm going to come to that in a couple of slides, but at least you understand the problem here. Everyone in the chat box, please.
Yes,
That we
I
face a problem
understand.
that finding the distance is not like the same as the Euclidean distance and the Manhattan distance, right? Chat box,
Mhm.
please. I need to see whether you're following me. Hamad, Muhammad, everyone else who's here in the chat box, please. Are you guys with me? Okay, great. So let's just I'm going to explain you on in a couple of slides. Okay, so but keep this question, and I'm going to, because there is a discussion we have to do before that. Okay, so I'm going to explain it to you maybe in like 2 3 slides. Okay, so let's look at the divisive method. Divisive method is again rather than going in this direction, in divisive method we actually go in this direction. So we start with A, B, C, D, E. We try to split, the first big chunk, first biggest chunk that we can see. So A, B, C, D, E is divided into A, B and C, D, E. Then C, D, E is divided into D, E and C. A, B divided into A and B. And then D, E divided into D and E. But, normally people do not use divisive method. They use divisive method, but
Doctor,
agglomerative, you only need to know agglomerative, for the sake of course. But I'm just explaining you what divisive method is. Just saying.
Doctor,
Yes.
I did not understand the divisive, what you said in before a second.
Okay, sure, no problem. So I'm saying that agglomerative, how were you going? You were like merging, right? You were merging,
Yes. Mm-hmm.
which means that you're going in this direction, isn't it? You're merging and then you're merging upward. So this is like the top,
Yeah.
right?
Yes.
So your
Mm-hmm.
direction is going like this. But
Mm-hmm.
in the other method, what you do is you start at the top. You start here. You
Okay.
start at the top. And
And
then you
we
divide. And then you
uh,
see the biggest division. And then the
uh,
next biggest division.
uh, Doctor. So we start from A, B, C, D, E, then we go to C, D, E, and
AB.
like A, B, and the last is D, E,
Then
right?
CDE is divided into C and D, and then D goes to D and
No,
E, and then AB becomes AB. So it goes exactly opposite, okay? So our direction goes from
okay.
here to here. Goes
So
from
we
here to
start.
here.
So, doctor, we start from A, B, C, D, E, and then C, D, E, and then A, B, and then D, E, and then A, B, we divided into two. C, D, E, we divided. D, E, we divided.
Yes, exactly. That's how we go. Okay, but you do not need to know both. We will just, in examples, we'll just learn how to do agglomerative in more detail. Okay. So, but
Okay.
conceptually, you need to understand that divisive is about dividing. Okay, rather than joining. It's the opposite thing. Okay, let's look at a few more examples. Let me just go back because I forgot to mention one important thing here. Yes, sorry, on this slide here. There is a name for everything. So, for example, this represents a data point. What kind of data point? It represents data point like this. This is a data point. This is a data point, right? Each of the data point, we call them leaf. Okay. The name for it is leaf. So this is leaf meaning one data point, another data point, another data point. So these are all called leaves. Okay. And
Okay.
then once you join two leaves together, we call this a node. The joining point, we call them a node. And we call them an internal node because it's like the inside of the tree. And then we call this branch, this long one, this one, we are going to call it a branch, internal branch,
Mm-hmm.
okay? And then we keep going up and going up and going up. And the last point here, it's called terminal node. The last point at the top is called a terminal, it's called the root, sorry, my bad. It's called the root. And the last branch that you see here, the last branch that you see here, these are called terminal branch. Terminal is usually mentioned for, something last. So this is basically the last branch. Everybody understand what leaf is, what branch is, and what node is?
For me, yes.
Okay. So this is leaf. Okay. These are what you call the nodes, and the vertical lines are called the branches. So keep this language with you, okay? Because we may need to use this language here. So uh, The number of possible dendrograms with n leaves. So what are leaves? I told you what leaves are. Leaves are
Leaves the number of the data points.
the number of data points. So when you say n leaves, you basically mean n
The
what?
number.
N data points. N is the number of data points you have. Okay. And then you would like to know so many different kinds of variation of dendrograms can you make? How many you can make? For example, imagine if there are 3 points. Okay, 1 point, the second point, and the third point. How many dendrograms can you make? So what we mean by that is that I'm going to draw it like this. Okay. So one of the dendrograms we can form is join these two together and then join this one together, right? And another possible dendrogram is we join this one first and then we join this one first, right? And then we join this one first and then we join, this with this one, right? So this is called possible dendrogram. So how many dendrograms do you see? We see one, two, three possibilities, right?
Mhm.
Understand what do we mean by possible dendrograms that we can create from these points?
Yeah.
So
The you mean
yes, sorry.
cluster three cluster?
Not just three clusters, but do you see that we can either join these 2 points first and then the third point, or these two first?
Mhm.
The possibilities, right? So
Yes.
so if I tell you I have 4 data points, so how many possible dendrograms can you create? So if you want to answer that question, you need to use this formula here given to you. Okay. So this is the thing.
Uh, Doctor,
Yes.
there is a symbol. How can we put it in the calculator after the three?
I'm going to explain it in a minute. Okay. Just give me a second. I'm
Okay.
going to explain. First, let me explain what this symbol is. So who can tell me what this symbol is? So if when I say not two, so when I say five and then this symbol, what does this mean? Who can tell me what does this mean?
Not real.
No, no, it's real number, but what does that mean? Who can tell me? Hamad, any other Hassan? Who can tell me what this symbol is? What do you call this symbol? What do you call this symbol? What is the name of this symbol, brothers? I think some of you must know what this symbol is. None of you? Multiple of five. No, not really, Muhammad. So maybe you're pointing towards that, but not accurately. Anyone else? Okay, let me explain you what this is called. This is called, first of all, this symbol. I'm sure you have studied it somewhere. It's called factorial. Now, anybody remember what factorial is? I'm sure you
Uh,
must have heard about.
we did not, Doctor. We did not study it. I don't remember it.
Okay, maybe you don't remember, but let's see if someone else is. No, it's not an imaginary number. It's not this I. This is not I. This is the exclamatory mark. Sorry, imaginary. We don't put dot at the bottom. We write I. We write like 5I. This is imaginary. Okay. So factorial basically means when you write factorial in front of any number. So 5 factorial basically means 5 into 4 multiplied by 3 multiplied by
Oh yeah, yeah. We take it. The yeah.
1. Now you understand what this
Mm,
is? Yeah, that's why I said you must know. You may have forgotten
eh,
about it, but so
yeah.
what is the factorial for 3?
Uh, 3 times 2 times 1.
Exactly. So if you need to know how many dendrograms are there, so what you do is you use this formula. So what is n? N is the number of data points. So imagine we are looking at number 4, right, as an example. So how do you write this formula? So you will write 2 multiplied by 4, right? 2 into
Mm-hmm.
4 minus 3. Sorry,
or
my pen
negative
keeps
3.
getting, strange lines. Factorial.
Yeah, it's not important unless we understand. Just
Yeah, so 2 raised to the power 4 minus 2, 2, right? And then again, 2 minus 2, 4 minus 2 is 2 factorial, right? Very easy to calculate. So 2
Doctor,
into, yes,
why you wrote? Oh, you wrote 2 because 4 minus 2 is 2. Yeah,
yes. So 2 multiplied by 4, right? So 2 into 4,
8.
8 minus 3,
8 minus 3, 5.
5 factorial. 2 into 2,
Mhm.
4. And 2 factorial is 2 into 1. It's 2, right? Then we
Mhm.
can write 5 factorial equals to 5. Instead of this, you can write 5 multiplied by 4 multiplied by 3 multiplied by
Doctor,
2. Yes.
but we still at the bottom we have 4 minus 2 is
No, no, not 4
2.
minus 2. 4 multiplied by 2.
Yeah.
It's a multiplication.
Oh, yeah, yeah.
Okay.
Yeah. Mm.
So we cancel 2 with 2 and we cancel 4 with 4. So 5 into 3. 5 into 3, 15.
Uh,
Can you just hold for a
5.
second, brother?
Oh, yeah. 5 times 3 is 15.
ड्यूटी है मैं चार थोड़ा सा मैं बिल्कुल शार्पली पहुंच गया ये क्लास खत्म करके आप फिक्र नहीं करें मैं पहुंच जाऊंगा आप मुझे एग्जाम पिक तो नहीं करना
मैं नहीं, अभी कितनी देर है मेरे पास? मैं इंशाल्लाह आ जाऊंगा, मैं कलेक्ट करते हुए एग्जाम से पहले 5-7 मिनट पहले, लेकिन आपको एंड वक्त पे पिक करता हुआ चल जाऊंगा। क्लास बस मेरी थोड़ी देर की रहेगी, ठीक? यस, सॉरी। सो डू यू सी दैट यू गेट?
Yeah, 3 times 5 is 15.
ओके, डायरेक्ट में कोएड 21 में ना, ग्राउंड पे। ओके जी, सॉरी। यस,
3 times 5 is 15.
या सो यू गॉट द सेम नंबर 15, राइट?
Mm-hmm.
Yeah, so that's how you calculate. Okay. Now let us just move forward because I have a little short time. I have another exam duty coming up at 4. So how do you find distances between any two people? So you do you see distance matrix here? So let's see how we are calculating distance. Again, first of all, if I gave you distance, how do you do agglomerative distance? Can you tell me which one is the smallest number here? Which one is the smallest number here in my distance matrix?
0, 1.
No, forget about 0. 0 is with itself.
Okay.
The next one.
1 and 3.
No, 1. Just tell me 1. So these two are the
Okay.
closest, right? Can you see that these two are the closest? What
How?
about, look, you see this one?
Okay.
And do you see this one?
Okay.
So you see where they are meeting. You see, you draw a line. So, for example, if you want to see this number is distance between this and this person, 4.
Mm-hmm.
What about this one? This one is the distance between this person and this person,
Mm-hmm. Okay.
right? So that's how you measure the distance, right? So if you want to see distance between these two ladies, you can see that this and this person, right? So this is 8.
Where?
I'm going to show you again. Let me clear this up. So between these two, so you identify one of them, right? The first one. And where is the second one? This is the second one.
Mm-hmm. Mm-hmm.
So what is the distance?
Distance is 8.
That's why we
Okay.
wrote 8 here. So showing you the distance. Okay.
Mm-hmm.
Now let's see. So what you do is, well, the closest one was 1. So you merge that one. Can you see that these two had smallest distance? Then you look at the next closest one and then the next closest one.
Doctor, can you show me how it is the closest one?
You can see it here. Distance between these two is 1 only,
Okay, you
right?
mean the number?
Yeah, the number itself. So you have to keep looking at the number
Okay. So, Doctor, can
because
you go back, please?
do you see that the distance here was only 1? Distance
So,
here was
the second was 2.
yeah. So you keep comparing. You keep comparing. This one was 8.
Mhm.
This one was 8. And so you
Mhm.
keep comparing and you merge only then the next one. We merged because they were the closest. And then you
We,
you keep
we,
merging the next closer one and the next closer one and the next closer one. Okay.
uh,
Again,
uh,
again, yeah.
I did not understand. Can you do it slowly?
No, I cannot
Uh,
do slowly because I need to show you something else before I show it to you again. Okay. But can you see that the closest one was this one, right? Do you agree with that?
yes, I understand this.
That's why we merged this one. Why? Because they were like the closest.
Okay,
Now you have to look at the distance again, the next closest one, the next closest one. Then you have to check. You have to see the next closest one was
one
um,
the two, the two.
yeah, the two with maybe this one. But we have a problem. We may have to compare it with this cluster as well, right? That's why do you see
Mhm.
that the next one, the next one, the next one? We are just explaining it conceptually. We are not still not solving the problem. Okay.
Okay, okay.
Conceptually, we are just seeing the next one, the next one, and the next one. We keep going up. Now, let me show you how we are finding the distances. So, when you're trying to find distances between two ladies called Patty and Selma, the way we are calculating distances, we are looking at their features: dress color, earring shape, hair type, right? And see how many are matching here, how many are different here between these two. Their dress colors are different, that's one. The earring shape are different, it's like a round and it is like a triangle, right? And the third point is, their hair look different. So you have 3 points which tell they are different. But what about Selma and Marge? Okay, you can see that their dress color is different, their earrings are different, their height is different. One is smoking, the other, the weight is different, right? That's how we were calculating based on the differences, we were calculating the distances. Okay, you understand how we are calculating the distances? It is
Mhm.
based on
The
it is
differences.
the differences. Okay, now there is one very important, and then there are more examples, like this difference between names. For example, have you heard about the name called Peter in English? Do you know the name Peter in English? I'm sure Peter Pan. Have you heard the story of Peter Pan? No, it's a
Okay.
name there is a name in English. Now the same name in Greek is called Petros. The same name in Polish is called Piotr. The same name in Irish is called Pieter. So and Pierre in French. Now it's the same name. Uh, like in Arabic we have Muhammad, right? But in Turkish they call it Mehmet.
Mhm.
So the same name, but the difference between across languages, right? So if you want to see the similarity of the same name across languages, here's like another example. So how do they check the differences between different versions of Peter? Well, this is how they were calculating it. Again, the differences. So Peter and they wanted to see the distance between Peter and Piotr. So one difference I can see here is that E and I, right? Can you see that? So if I change E with
Mhm.
I, I'm getting closer to Piotr. Then what else? There's an extra O in between here. So I added O, I insert O, and then I removed an E. So I took 3 steps, one, two, three. One substitution, one insertion, and one deletion. So you can use substitution, insertion, and deletion as well to identify differences as well. So there are different ways to do it. I'm again showing you examples of how non-numeric data is being treated. Now, one of the biggest questions that I want you to pay attention, okay? And by the way, in terms of exams, next class I will bring examples of all possible things, that type of question that can come in the exam. So please do not worry if you're not getting it fully, but please make sure that you study the theory behind it, okay? Now, if you want to see distance between this cluster and this cluster, how can you find distance? Because we used to find in Euclidean distance between one point and another point, but we have so many points in there. So how do you find distances when you're dealing with clusters? So there are four methods. One is called single linkage. Then we have complete linkage, okay? Then we have something called group average, and then we have something called centroid. Let me ask you a question, which will make your mind clear. So what is the distance between, if I'm going from here to Riyadh, how much is the distance? Hamad says 400. What about others? Do you agree with that? Hamad says 400 between the Mom and Riyadh.
I
400.
don't know.
Abdulaziz says 400. Muhammad says 400. But let me now ask the question more clearly, okay? When you said 400, you're thinking about distances when you just leave the city and when you enter the other city, isn't it? Isn't this what you are trying to say? The distance on the highway almost, right? Hamad Abdulaziz Muhammad, I think, right? That's what you have in mind. So that's what you call single linkage, because you had the single linkage in mind where you look for nearest to nearest. It's called nearest neighbor, okay? Which means that you're looking at the two nearest points, and that's what you call the distance between two clusters, nearest one. But it may not be the case, because I may be living in the other at the Mam Cornish, and I have to reach maybe the other side of Riyadh, maybe the Laban, or some faraway areas near where you go towards Makkah, right? If you say so, then it's not 400 kilometers, because that's not what I'm looking for. It is far more if you consider from edge to edge, the farthest to farthest, right? Then if you're looking for the farthest to farthest, we call that complete linkage. Everybody understand that is the difference between how we are measuring distance?
Yes.
And then we have something called group average. You take the average of all points and you use that average. And the third point is called centroid. So let me just see. Let me just show it to you. Let me clear the screen. Single linkage. So this is called single linkage. Can you see nearest point? And then we
Mm-hmm.
have something called complete linkage, the farthest point. Group average. So we have group average. We take average and then we take this distance. It's like city center to city center.
Yes, but doctor, how can we understand clearly in an example? This is a visual, not a real example.
I said I'll talk about the real examples later, right? I don't have a time now, so understand it conceptually. Next class, I'm going to talk more about that. I can explain you what kind of question that will come, okay?
Okay.
And then the centroid and averages may look the same. But uh, everybody understand, the difference between single, complete, group average, and centroid. So which one would you use in your analysis? Well, it has to do with the problem itself. If the problem is that, like, going in general for, let's say, between cities, then maybe use this one. But
Single.
if you say I'm going from city center to city center, like from the Mom center to Riyadh center, I may use group average. But if my problem is how I live in the other side of the Mom and I have to pass Riyadh, what is the distance? Then so it has to do with managerial problem that you choose the right one. Okay. So then you use the complete linkage. So complete linkage group, it has to do with both. But the thing is that, and by the way, this is just the formula for what just I explained. So grow single linkage means the minimum distance. Take the minimum distance, take the maximum distance, take the average distance. Okay, so do not be bothered by this formula. I already explained it to you. But the point is, when you use one method over the other method, what do you see? If I use single linkage versus complete linkage, is there a difference in my dendrogram? Is there a difference in my hierarchical clustering? Do you see any
Yes.
difference? Yeah, so it is
Uh,
very sensitive. So your wrong choice will lead you to long clusters.
Doctor, it seems like the complete linkage is more clear and the average is clearest.
No, I mean you cannot tell which one is better over the other. It depends on the use. You know what the purpose. It depends on the purpose that you're using it for. Okay.
Okay.
So
Mm-hmm.
managerially you pick whatever, but the point that I'm trying to make, if you're dealing with single linkage problem, which managerially make more sense, and you use average, your answers will be different. You know, it's not the same. Not the same, right? Yeah, it looks
Mm-hmm.
different. So that's what I'm saying, that you have to pick the right one managerially. So this is, instead of choosing K, the problem in dealing with hierarchical clustering is that you have to pick the right centroid distance formula. Okay, so this is centroid distance formula is important. Now, in summary, you do not need to specify K, the number of clusters. Uh, you can create a hierarchical decomposition by any number of data points, you know, in a agglomerative and divisive way. It can give you more insight, more deeper insights, okay? But if you start wrong, using wrong distances, you know, you may end up with, there's no improvement, you know, you just create. So it may take you to wrong answers. Now, I just want you to see the difference between partition and hierarchical. This is like K-means. This is like K-means and this is hierarchical. So it gives you multi-level clustering. We already discussed that. It only creates like a single level cluster. So this is the difference between partitional and hierarchical clustering. Now I'm going to stop here.
Doctor?
Next class, just a second, because I have less time left. So let me tell
Mm-hmm.
you something very important. Next class, what I will do, and it will be a very important class for you all, is that where did I keep? Next class, what I will do is I'm going to, let me share something else again. What I'm going to do is I'm going to give you example problems that may similar to that that may come in the exam. Okay, so it will help you prepare for the exam. So next class is important. So there
Okay,
will be
but
one.
Doctor, can you just go back to the last slide? I did not understand the partition and hierarchical, the difference you mean. What do you mean?
Uh, I
Just
this is from the first
just go back
chapter. Yeah,
one
yeah,
one minute.
I'm going there. But actually, my another thing is starting very soon. So it just says one small thing. Okay, so let me just go there quickly. It
Mhm,
basically says that partition only divides into one level, single level, right? Like this is one level,
mhm,
but not level after level after level, not multi-level.
mhm.
You are not able to see distance between these two or these
Okay,
two. But here you
okay,
can see the distance between these two and these two and these two, each one.
okay. Yeah,
Yeah, that's
understand.
what we are saying. That within the cluster you cannot see the differences within the cluster. But in
Mhm,
hierarchical you can see the distances between clusters. Okay.
mhm, mhm.
Now what I was trying to tell you is that next class, inshallah, I will be bringing these practice problems to the kind of questions that might come.
Mhm.
Because we are having relatively shorter classes, so next time please be prepared. I may have to
Okay.
cover a little lecture, and then I may have to do, you know, some of these examples to show you. Okay.
Mhm.
So please come prepared next time. Please, no excuses. Even if you have something, please come prepared that we may have at least like we may have even 2 hour class. Okay.